Okay, this video is going to be over similar triangles. We've already talked about similar figures. The warm-up says since both sides of both side lanes and the perimeter are one-dimensional measurements, what we talked about in the previous set of notes was that the ratio of any two corresponding sides, or finding the scale factor, is going to be the same as the perimeter's ratio or scale factor. So here we're given quadrilateral MNPQ. We're going to create quadrilateral XYZW, and we want to find the scale factor and the perimeter of each polygon. First things first, we have to find our scale factor. Remembering that scale factor is going to be new over old. Our MNQP is our old original because it's written first. XYZW is the new because it's the newest one written down. So here, this one right here, XWZY is the new. So they even put it in a different order here in the diagram, so you have to pay close attention. So what we need to do is we can only use one side of the new, that's going to be segment WX. We need to figure out which side this corresponds with. So WX, those are going to be the outer two, the first and the last letter, so we need to match it with the first and the last letter of the old diagram here, and that's going to be MO. So we go over here to MQ. We go over here to MQ, and we're going to pair it with 8. The new has to go on top, which is going to be the 4. The old 8 goes on bottom. This will simplify down to 1/2. Make sure that you are simplifying your scale factor. 0.5 is also accepted. Now, what we need to do is we're going to find our perimeter of what we have, the old one. So to find the perimeter, all we're doing is adding all sides together. 8 plus 9 plus the 10 plus the 7. When we add all 4 together, we're going to get 34. So now we need to use proportions to figure out, using the scale factor, how can we find our perimeter. Our scale factor ratio was 1/2. And then on the other side with our proportion, we're going to look up perimeter. The ratio right now, okay, remember we had new over old. The new of 1, so we need the new perimeter. We don't know what that one is, so that is our X. The perimeter of the old one was 34. So all we need to do here is do our cross multiplication. We end up with 2 times X equals 1 times 34 is 34. And then all we do is divide by 2 to solve for X, and we find out this is going to be 17. So right here we have the perimeter of PQ right here was 34, and we found our new perimeter of 17. Now, similar triangles have corresponding angles that are congruent. We've already talked about this. And they have corresponding sides that are proportional. Why we use proportions with this. There are going to be 3 different ways that you can prove that 2 triangles are similar. This is a little different than proving 2 triangles are congruent. The first one is the AA, angle. You are not allowed to use this one with congruent triangles. You can with similar, because no matter how much bigger or smaller proportionally you get a figure, all angles will be the same. A scale model of the pyramids in Egypt, the angles are exactly the same as the actual pyramids in Egypt. So here, looking at AA, all we need are 2 angles because the third angle will automatically be congruent. So here we're looking at if angle A is congruent to angle D and angle C is congruent to angle F, we don't need to worry about it, because if you use triangle sum theorem, you're going to find out angle B and angle E are the same as well. So looking at these 3 right here, we're going to say, can we prove these by AA? And then if so, we're going to write a similarity statement. What I need you guys to see here on this first diagram is you have 2 triangles. Okay, I'm going to use my different colors. You have the large triangle right here, triangle ADC. So here, let's go ahead and draw in triangle ADC separately. Here's D, here's A, here's C. We're seeing here that this is 52 degrees. Then we have the smaller triangle AEB. A, E, and B. And this guy over here is 52 degrees. What we need to see here is that they have a shared angle, angle A. That means angle A is automatically going to be congruent. So with congruent, you're going to have to do it here too. Shared sides and vertical angles, you also need to look for shared angles. That gives you an A. So here we have an angle congruent, and it's supposed to be an A. An angle congruent. All we need are the two. So this, we can say, yes, these are similar, so we need to keep our corresponding parts together. Angle A will correspond with angle A. So here, let's say we have angle ACD. This will be similar to triangle ACD. Over here, A will correspond with A, C will correspond with B, D will correspond with E. In the next problem, we see here that angle, we've got some markings, okay? We've got an angle with one marking, we have an angle up here, C, with two markings, and angle B over here has three markings. We also have vertical angles. So again, still looking for vertical angles. Now because we already have 1 mark, 2 mark, 3 marks, we are going to have to put 4 here. And what's going to happen here is only one pair of angles has the same amount of congruency marks. K has 1 congruent mark. It doesn't have a match over here. C has 2 congruent marks. It doesn't have a match. B has 3. No match. So all we have is one angle, pair of corresponding angles congruent. So are they similar? No. And we're going to write in only one pair of congruent angles. You have to have 2. On the last problem here, I'm seeing vertical angles. So we need to mark those congruent. We can put 2 marks because we only have 1 on these other ones. Now we're seeing here that angle J is congruent to angle F. And then we have our vertical angles. So we do have congruent angles right here. That's right, I only like to write it on one of them so it doesn't get confusing. And then we have another set of congruent angles here. So we do have similar triangles. And here we'll name this triangle. I'm going to start at J, then go to K, and then H. We're going to say this is similar to triangle. J corresponds with F, K will correspond with G, and the vertical angle H will correspond with itself. Please pause, rewind if we need to. I know I'm going fast. The next one is your side, side, side. We do have a side, side, side with congruent, but the issue here is with the side, 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 these corresponding parts of all 3 sides must be proportional. So we have to set up the ratios to see if they are all coming down to the exact same ratio or scale factor. So this is where we look at the small, medium, and large sides, okay? So here we're looking at these 2 triangles. I'm going to go ahead, I'm going to keep using, usually it doesn't tell us which one's new and which one's old, but a lot of times the first one written on the left is the old, this one's the new, so I'm just going to keep it with that. So here we're going to take a look at our small, medium, and large sides, making sure that we're labeling both. And to make sure that we are keeping the ratios correct, what's in the numerator, what's in the denominator, I'm going to be putting triangle VWX in the numerator, and I'm going to put triangle UTS in the denominator. Let's look at the small sides. We're looking at the small sides. I want VWX first, so the 9, over the corresponding small side of 3. This simplifies down to 3. Looking at the medium, we want VWX first, the medium was 12, over UTS's medium of 4. It simplifies down to 3. So far, so good. Okay? Always check the last side. Here, I don't know why I'm circling it, because I'm going too fast. Over here, VWX, the large side was 15. Over here, UTS, the large side was 5. And this does simplify down to 3 as well. So because all 3 sides, corresponding sides, have the same ratio or scale factor, we can conclude, yes, triangle UTS is similar to triangle VWX. Now, the side angle side, we have one with congruent triangles as well, but again, we're not looking at congruent sides. We need to have that we've got one pair of congruent angles. A is the angles, and then the sides that create that angle are proportional. Again, looking at, we have to have the angle has to be included. So here we're looking at BC and EF have to be proportional, and CA and FD have to be proportional because these are the angles included between them, why the A is between the two S's. So this example here, we're seeing that we are dealing with the included angle on both of these. So this one, you could go ahead and verify, yes, I do have my A. I've got my congruent angles. So now instead of doing all three sides like SSS, you only have to do two sides, your small and your large side. So here, your small side and your large side. On the other triangle, here's small and here's large. Okay? I'm going to stick with the one over here on the left. We're going to say triangle PQR. I'm going to put in the numerator. And over here, triangle MLN. I'm going to put in the denominator. Looking at the small sides, PQR first. Small is 6. Over here, the other triangle, the 4. Simplifying down to 3/2. Now we'll look at the large side. Over here at PQR first, because that's what we put on top. That's why we have my legend or key right here. Let me know what to put on top and which to put on bottom. The larger side, we have 9. And on MLN, the larger side is 6. All simplifying down to 3/2. So we do have two proportional sides, and the included angles are congruent. So these are going to be similar triangles. So yes, triangle MLN is similar to triangle PQR. All right, we have 3 more examples looking at, are they similar? If so, by which theorem, as well as writing in that similarity statement. Okay, so the first one, letter A over here, we have these two different triangles again. We have the larger triangle right here. This is going to be a little different than what we did earlier. So this is going to be triangle JLN. Okay, and we're going to come back and label the sides in a second. And then we have right here, we have triangle KLM. Now with the smaller triangle, we can see that this side is 6 and this side is 10. What we need to see here with the larger triangle, it's not 5 and 3, ladies and gentlemen. It needs to be the entire thing of 15. We'll see this in another lesson where we're going to have to do this stuff like this. This entire side, JL, is going to be 9. So that's what we're labeling here. Now, we don't have all 3 sides, so we need to test for SAS. Also, what we need to see is the shared angle. Okay, your shared angle means this is our A. So that's why we can test for SAS. So let's go ahead and set up our ratios now. We have our small sides and we have our large sides. Okay, if we set up our small sides, we'll go ahead and put, I'm just going to put the, it honestly doesn't matter which one is which since we're not looking at scale factor. If we put 6/9, this will simplify down to 1/3. The large sides, because I put the smaller triangle in the numerator, I have to keep the smaller triangle in the numerator, so I have to put the 10 in the numerator over the large side of 15. This also simplifies down to 1/3. So we can say triangle KLM, it's going to be this, I put the smaller one here, is going to be similar to triangle, but KLM, we need to go JLN. And this will be by side angle side. All right, let's take a look at B. B here, we've got 2 different triangles. Okay, we got this guy right here, and we got this guy right here. What we need to see here is we only have sides, we don't have any angles, so we're testing for SSS. So we need to look at our small, medium, and large. Looking at the top triangle, here's our small, medium, and large sides. The bottom triangle, okay? Well, we need to find EF. Please note that EF is both of these sections together, making it 12. Okay, be careful with this problem. So now we have small, medium, and large. So let's go ahead and set up our ratios. Small, I'm going to go ahead and take this top triangle, the small side 3, over the bottom triangle, small side 6, simplifying to 1/2. Let's look at the middle or medium sides. The top triangle went in the numerator, so we got to keep the top triangle in the numerator. The medium or middle side is 5. The other triangle's medium or middle is 10, 1/2. The large, the last remaining, the top triangle was 6. The bottom triangle was 12. We have confirmed all 3 sides have the same scale factor or ratio, so they are proportional. So here we can say they are going to be similar, so we can say triangle EDG is similar to triangle FHE by SSS similarity. All right, last one over here. First thing that we need to notice, we can do this 3 different ways, okay? We can do this, oh no, we can't, yeah, we can do this 3 different ways because we have this side length up here. I'm gonna let you know right now, I'm just gonna use the, I'm gonna test it by SAS because it's one less proportion I have to do. How that works is I have vertical angles here, okay? So because we have these vertical angles, I don't need this 6. I don't need this 15. I can test for SAS instead. If you want to test for SSS, please go for it, okay? But here I'm going to test for vertical angle with our vertical angles SAS. So I've got my small and my large side here. I have my small and my large side here. So looking at the small sides, I'm going to use the top triangle first, 5 over 12.5. This is going to end up coming out to, in our calculators, it's automatically going to give you a decimal. 2.5, it's perfectly fine. And we'll look at our large sides. Top triangle is in the numerator, 8. Bottom triangle in the denominator, over, I'm sorry, not 2.5. Sorry, I went the opposite direction on that one. Going to end up being 0.4. Over here, we've got our 8 over our 20. And because this one automatically came out to a decimal, this one's going to end up coming out to 2/5. Sorry, I'm writing this all crappy because I'm trying to rush. Here, it's the last one. Slow down. This ends up 4 goes into both of these, making it 2 over 5, which does come out to a 0.4. So now that I have proportional sides and the included angle of both of them are congruent, we can say that triangle QRP is similar to triangle TRS by SAS. All right, I know I went fast. Please rewatch or search my YouTube PHS Collins. Search it for other videos I have of similar triangles. I know the most recent before this is the exact same video pretty much, but maybe I went a little slower, or ask your teacher for any additional help.